In this first part of section 2.3, we're going to talk about the different types of linear equations and how to move the equations around when we need to. So the first form of a linear equation is probably the one you're most familiar with, and we have talked about this one before. That is slope-intercept form. So remember that looks like y equals mx plus b. So m, remember, is our slope, and b is our y-intercept. Now remember, what makes this linear, what makes any equation, is that our x variable is to the first power. So it's really easy to spot slope-intercept form because what you'll notice is that y is all by itself on one side of the equal sign. The next form of a linear equation is also one we've looked at before, and this is standard form. So standard form looks like ax plus by is equal to c. Now, first of all, what I want you to notice is that x and y are on the same side, and that the constant is over here on the other side all by itself. But there's also a couple things about standard form that you might not realize. But one thing is that we cannot have any fractions. So there will be no fractions in our standard form. And the majority of the time, we try to make sure that x, or the coefficient of x here, a, is always positive. So a is positive. But again, the way that we can tell that this is standard form is that x and y are on one side. We don't have any fractions, and most of the time, our a value will be positive. The last form we're going to talk about is point-slope form. So this is actually very useful when we're going to be writing equations later on in this section. So what this looks like is y minus y1 is equal to m times x minus x1. So m, just like in slope-intercept form, is the slope of the line. And then these other two values here, y1 and x1, those come from an ordered pair, which is any point on the line. So unlike slope-intercept form where we need the y-intercept, in point-slope form, all this gives us is the slope and some other point on the line. It doesn't necessarily need to be the y-intercept. Okay, so now we're going to look at three different equations and just determine what form they're in. So if we look at the first one, what we notice is that y is all by itself. So this immediately lets us know if y is by itself and x and the constant are on the other side, that this is slope-intercept form, the form that we are most used to seeing. The second one, x and y are on the same side, and we have no fractions, so we know that this is standard form. And then finally, this last one here, what we can see is that y is on one side, and then over here we have this multiplication, so this is our m times x minus x1 right over here, so this is that point-slope form. One thing that's going to be really important for you to be able to do is to take a linear equation that is not in slope-intercept form and rewrite it in slope-intercept form, because again, this is the easiest form to graph. So this first equation here is given to us in point-slope form. So remember, to get it in slope-intercept form, we need to isolate y. So in order to get rid of this minus 5 over here, we have to clear the parentheses on the right-hand side. So our first step is going to be distribution. That will give us y minus 5 is equal to negative 2x minus 6. Now that the parentheses are gone, we're able to go ahead and move the 5 over by adding it to both sides. So that gives us y is equal to negative 2x minus 1. And now we have y by itself, so it's in slope-intercept form. This negative 2 is our slope, and this negative 1 is our y-intercept. Okay, now we're going to take this equation that is in standard form, because again, x and y are on the same side and we have no fractions, and we're going to rewrite it in slope-intercept form. So just like the last one, what we want to do is we want to isolate y. We want to get y all by itself. Well, the first thing we need to do is move the x term over to the other side. So when we do that, we're going to have 5y is equal to negative 3x plus 30. Now notice that I'm putting the x before the constant because we want this in slope-intercept form, which is y equals mx plus b. Now all we have to do is get rid of the 5. So remember that every single term in the equation has to be divided by that 5. So that will leave us with y equals negative 3/5 x plus 6. So now that y is isolated, we see that negative 3/5 is the slope of the line, and our y-intercept is at 6.